Hello, this is Iznogoud from the empeopled Discord, and I decided to make this video such that I can guide most people that have an interest in what we're trying to do when it comes to the technical component of this. So what I have here is the website of empeopled. So the website will take you to the Discord, and you can join and read whatever there is to read there. Now, the point of this video is not to be overly technical, but to have sufficient technical guidance for anyone who's trying to look at what we've created. And what we're trying to push forward is on-chain governance. That is a governance mechanism that anyone can use to launch their own country on-chain, and in this case, using the Ethereum blockchain. It can be used on other blockchains that are compatible with the Ethereum blockchain, or what we say the Ethereum EVM, virtual machine. And anyone can use it. It's open source, and go look at the GitHub repository for all the files. So what I have here is the GitHub repository, which is on the empeopled GitHub profile. And this is labeled empires here. What we're going to do is we're going to walk through what these contracts are and what they're trying to do. And then I'm going to show you how to actually try to test them and deploy them using the Remix EVM IDE. It's an online interface for development, an IDE that you can launch in your browser. And finally, we're going to look at Etherscan. This is just an example of a contract to see how one can interact with it. So let's get to the GitHub repository. Let's try to make this short. What you can see here is all the files that have been put together after we try to build an MVP, so a minimal product. Of course, this is open source. We haven't put any licensing on it. This is up to the community to decide how this is going to be distributed. But as far as we're concerned, this is an open source project. The important files here are these emp laws, which is the main contract. Then the interface, which is effectively a class prototype for what governance contracts look like. The default contract for governance, which is effectively a monarchy or dictatorship, as we call it. And then a placeholder for what will be something like a democracy. This is presently not functional. It's a placeholder. So let's just look at these files. And I should say that we've included a token prototype here, which we're not going to discuss right now. So the actual country starts to be in existence. It starts existing once a contract like this one is deployed on chain. And what this contract does is makes reference to a governance, the actual governance layer, meaning a decision-making process. That's this interface. An interface is simply a prototype to a different type of contract. So that if your contract is, say, a type of object that you're going to be interacting with, or this specific contract, the laws contract, what we call it laws contract, is going to be interacting with, it needs to know what it consists of, how to interact with it. That's described in the interface file. Now, if you look at this laws contract that we created, it is very, very simple. This is extremely minimal. It contains internal members, such as the founder address, purely for historical purposes, and a timestamp for when it was created, such that it can be queried by anyone. You can look it up. Internally, there is an address that stores a reference to a governance contract. So this variable stores a government contract address. What happens is the country is governed by a number of interactions that happen through this contract. That is, you access members of this contract, as we'll see in a second. Any law in the country is effectively this struct. So it's just a component that is an associated contract address. For historical purposes, there can be an author, someone who proposes that law, a content description, that's the string, and then a status, which is for managing how the contract is deployed and used in the country. All the laws in the country are stored in this map, which maps addresses to any one of these law structures. And these can be added, removed. Now, how you deal with these laws, what these laws do in your country or organization or entity is a whole separate issue. The whole point of this is to have a way of putting together these laws for this specific country and being able to interact with them. So any interaction that would happen with any one of these laws will have to happen through the associated contract address. So any logic, any mechanism that this law has in terms of some programmatic behavior on the blockchain is going to happen through this address. That is something we're not going to discuss now. So any law that's added to this country goes into this map. And so from the address, you can query this by interacting with this contract. I'll show you how to do that in a second. Once a country is deployed, once a country is started, the constructor, which is effectively a function that's executed when you deploy this contract, is going to go through this specific logic that's listed here. For example, the founder address has to be provided, meaning that somebody who starts their country and deploys that contract for the first time has to provide an address. It doesn't have to be their own, it can be anything. And so that's stored. The creation time is stored from the block that is actually minting that contract, deploys that contract. An initialization of the log count to 0, initially having no laws, goes in place. And here's the important part. Initially, the governance contract is deployed as well from the deployment of this contract. And in this case, it is this default that we see here. I'll show you what this default does. But let's just say for a second that this is a form of monarchy. Once that government contract is deployed, it is stored such that the internal member of this country's storage points exactly to this contract here. It will make references through this address for anything that happens in terms of amending, adding, removing laws, amending them, and even self-referentially changing the governance mechanism itself. That is to say that this specific address can change. So we can make some kind of change in governance to, say, from dictatorship to some kind of federated republic or some democracy or something like that. What we would do is we would have to externally mint a new contract, not the default one, but something else, something we will have to draft, and then reset this address to point to this new contract. I'll show you how this is done as well. So let's get going with this. So suppose that we want to change our governance. What will happen is first we will deploy this contract here, which will become a de facto dictatorship. And then this method, set governance contract, is going to be accessed, meaning there will be an interaction on the blockchain by someone. It doesn't have to be the founder, it can be anyone who sends a different address. Now this address is going to be tested effectively here for whether it's valid, whether other conditions are met. And if it's approved, the government's contract of the country is going to be set to this incoming one. The conditions that have to be checked, like for example, in this dictatorship, suppose the dictator has to approve that they relinquish power and somebody else takes over with a different contract. Through this decorator here, this modifier, there has to be a check. So the process goes like this. Someone interacts with the present contract through this method, providing a new contract address for governance. This new contract address for governance is checked through this modifier. And if this allows the process to proceed, it will set the internal contract of the governance to this new one. And therefore, we have a new government. This is the self-referential part. The modifier that does this is listed right here in this listing. Ignore for a second the debugging and testing that we do here through the Ethereum remix. And let's go straight to the actual change of governance. What this does is it actually goes and creates an instance of the governance contract that's already set inside the country. And then, now that it exists as this variable how, it will go through a check by calling this method, giving the new government address and whoever interacted in this particular case when they called this method here. So what happens is we delegate to the instance that we have deployed on chain of this how contract this decision. If this returns true, then the modifier will allow for the process to go through, which means that this will succeed and the change will take place. A number of other functions are included in here for changing laws, adding laws, and so on. We are not going to worry about those for a moment. Let's just go to the governance layer. So this how contract initially was minted with this contract of the country, meaning the establishment of this country right here, when it's deployed by simply calling this new operator. This default contract is prototyped after this interface. So let's look at what this interface looks like. This is the interface for a governance contract. There are some functions here for testing, like simple ping, for example. You can ignore that. But let's go straight to the action. Changing the decision process. Remember that this function was called by the laws contract through that modifier with the incoming, let's say, proposed new governance contract here. And of course, there is a sender address, as we said. Now, this function here has to be authored by someone when they make an actual implementation of a governance contract. Let's look at an actual implementation. Let's go to the default contract, which is what we use when we deploy a country by default. So this is the default contract. And this default contract we have as a dictatorship. So we have an address that is set with the dictator's actual address. The actual address of the dictator is set in the constructor. It's coming in, and then it's set right here. At this point, the only possible change to governance, for reasons of making this robust, is to have this specific contract that we're deploying the only allowed contract for changing governance. This is an esoteric thing to how we built this dictatorship, so it just doesn't fall apart. Meaning you can't just change it without approving a specific contract. In this case, what we do is we have another function where we initiate a change. So what would happen is the dictator, should they want to change governance, they would have to call this function on their own and provide the address of the contract to which they wish to change. That's why the allowed contract is set to be the new incoming address. So what then would happen is when the check takes place from the country to change its governance mechanism, only if the proposed contract matches what's stored here by the dictator, it's going to allow for the dictatorship to change and become the whatever else this incoming member is. You can look at all of this on your own and try to ponder how this works. We've tested it, and we are ready to deploy it and try it out actually on chain. Let me show you quickly how you can test these contracts on your own. You can go to remix.ethereum.org, and you can load these contracts up on the left by uploading them. It's very simple. In this case, I've pre-uploaded all of them. Let's look at the actual laws contract, which is the country contract. Looks identical to what we have on GitHub. If you put your mouse anywhere on these members, it will provide information about it. So it becomes a little bit of clutter here in this video, but we're not going to worry about that right now. Deploying this contract to test. First of all, let's compile it and make sure that it compiles. I click on that green thing, and as soon as it compiles, it will tell me that everything is good, compilation successful. I can just go and test it now and deploy it. So clicking over here, deploy, it brings me to an actual EVM, a virtual machine of the Ethereum blockchain. you can actually go and interact with the blockchain itself, but we're not going to do that right now. We're simply going to use one of these remixed based EVMs where testing can happen. And in this case, it gives us a number of addresses that we can use that are preloaded with 100 Ether. So this is the first address. I'm just going to copy this address because I need to provide it as a founder address when I'm in my country. So now that the actual contract for the country has been compiled, all I have to do is interact with the deployment of it. The deployment requires an address, which is going to be the founder. So I'm just going to copy from here and paste it in here and simply deploy. Once the deployment takes place, you can see down here, there is a new contract that came online. It says deployed contracts. And you can see that the interaction cost me something. Instead of 100 Ether, I had much less. Well, maybe not that much less. Okay, so now here is the contract. The contract has all these methods with which we can interact. Like, for example, we can look at what the log count is. Remember that this was set by the constructor to be 0 right here. And so if I try to query the log count, it gives me the address of the interaction here, and it says that the number is 0. There is nothing there. In order to add a law, in this case, we would have to deploy a law contract and then paste it in here and deploy. And given our governance, acceptance, rejection criteria, this can either take place or not take place. I am not going to try this now. You have to experiment with this on your own. If you want to actually deploy this on chain, you can change from an EVM to the actual internet provided blockchain and use your MetaMask wallet and deploy a country. It is that simple. You will be the dictator if you do that. Once we have a country in place, anyone can interact with it. In fact, you can go to Etherscan and find the address of a contract. And once you navigate to it, it will look something like this. This is just an example. I just picked a contract that I found on chain, and I have done nothing to it. Once you deploy your country, the contract page will be like this with a specific hash that corresponds to the laws contract. We can upload the code, which Etherscan will check whether this is the actual contract that's deployed, and then you can actually look at the code. So for example, once we will have uploaded it, if it approves, it will be right here. This is the actual code of the contract that I'm showing right now. And then any interaction we want to perform, we can actually perform it by connecting our MetaMask to Etherscan and actually interact with this contract. So this is all I have, and we'll discuss this on the Discord. Of course, if you have any questions, you can message me directly.